I'm Mark Kavanaugh from Cavi Coaches, and today I'm going to coach you up on mechanical power. So in this video, we're going to talk about mechanical power. It's the rate at which energy is transferred. And we know that energy transfer is work, so power is the rate at which work is done. So if we look at a situation of work being done where we are being lifted up by stairs, if we run up those stairs, we know that the time is going to be very small, so that means the power is going to be large. But if we walk up those stairs, it's going to take more time for us to walk up those stairs, and we can see that it will take us more time and the power will be smaller. So if you think about how you feel when you get to the top of the stairs, you're going to be more tired when you are run up the stairs versus when you walk up the stairs. It's showing that you've exerted more power to get to the top of the stairs by running. Now, if we look at power in equation form, power is a change in mechanical energy divided by time. Well, we also know that a change in mechanical energy is work divided by time, which shows us that when we're dividing something by time, that is a rate at which work is done. So it's the rate at which energy is transferred into or out of a system. So if we delve into that equation a little bit further, power equals work divided by time. We also know that work can be calculated by the force parallel to the direction of motion times the distance. Well, if we look here, we have distance divided by time, which is the speed or the velocity. And so that means we can calculate power by doing the force parallel times the velocity. Now, if you think about pushing a box at a slow, constant speed, that means you're not going to exert as much power. But if I push that same box at a faster, constant speed, well, I know that the force is going to be the same because Newton's first law tells me that the speed is constant. So the force parallel is going to be equal to the friction force. So the thing that's going to show I exert more power is that I have it moving at a faster velocity. So by calculating the velocity and knowing how much force that it takes to push that object, then I can calculate a power by doing force times velocity. Now the unit for power is a watt, and a watt is defined as a joule per second. And if you break a joule per second down a little bit further, a joule is a newton meter, a newton is a kilogram meter per second squared, so that gives us a watt is a kilogram meter squared per second cubed. But it's really just showing us the rate at which energy is transferred. It's named after the Scottish engineer James Watt, who perfected the steam engine. Another unit of power, the British system, that you might be a little bit more familiar with or heard of is horsepower. Horsepowers are usually engine ratings for cars, and 1 horsepower is equal to 746 watts. So 1 horsepower, 746 joules per second would be a power rating. Most power ratings on cars are in the hundreds. A very large horsepower car could be 600 horsepower. Now, if we look at a graph, a power from a graph, if we were graphing work measured in joules versus time in seconds, and we ended up with a straight line graph, what we know is that power is the rate at which work is done. And we know that a rate on our graph is the slope is the rate of change. So therefore, the power is going to be found by using the slope of the work versus time graph. So if you're given a graph, we know that if you're asked to find power, power is just found by utilizing or finding the value of that slope. This is an introduction to mechanical power. I hope this was helpful, and I hope you have a great day and an even better tomorrow. If you found this video helpful, click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.